Andrew, Professor McPherson. Andrew and I sort of crossed paths briefly just a few years ago. We were both at the Media Lab for different reasons. And I've been peripherally aware that he moved to London. It was for 11 years, I think you said, at Queen Mary, where there was a fairly large group working on what I think of as music technology. And there is definitely a strong overlap between music technology and HCI. That's indeed how I personally got into HCI, but that's an aspect that surfaces in some of the work at UCLIC, especially like Anisha and Nadia's work, but we don't have people who, at least as far as I heard, think of that as their main sort of slice of HCI. So I thought that it would be great to get Andrew to give a guest seminar and tell us more about that and get us all to think about what intersection there is that we could do interesting work in and possibly collaborate with Andrew and his team between Imperial, and you still have connections with Queen Mary, you were saying.
Absolutely, yep.
Right, so thank you for coming.
Great, well, thank you, Enrico, and yeah, thanks for hosting, and thank you, Duncan, as well for the invitation. I'm so happy to be here. I'm gonna talk about some recent ideas that I've been kind of kicking about in my work at Imperial. And before that at Queen Mary, where I was up until the beginning of last year. Just sort of fair warning, this is going to be somewhat of a kind of theoretical and speculative sort of talk. I'm going to give you a couple practical examples from the work that I'm doing in my research lab on musical instruments, but also maybe just try to use that to motivate some deeper questions about what we're actually doing here in designing interactive technologies and ways that we might kind of reconceptualize some of our thinking around designing interactive systems. This is work that I'm doing with my research lab, which is called the Augmented Instruments Lab. So basically, a lot of the ideas come from these people here, PhD students and postdocs doing a wide variety of things around music technology and HCI more broadly. If you want to know more about what the lab does, head to the lab website, instrumentslab.org. The publication list at least is up to date because I just updated it. Not necessarily so much the rest of the site, but you know how it goes. You can get a sense from these pictures, right, of what's that the work that the lab does is around new musical instruments, oftentimes incorporating digital technology in various ways. And a question that I think comes up with this is really, okay, well, why? Why would we make digital musical instruments? Why is this a valid way of spending public funds in order to, to conduct research? What's so hard about this? You could, as of 2011, download the GarageBand app for iOS and make music on your phone. Job done, right? Well, then, but then you have things like this. Here's so this quote is from Bill Buxton, who is saying that you have 3 levels of design. You have your standard spec, you have your military spec, and you have your artist spec. And of course, the third of these is the hardest and the most important. But if you can nail it, then everything else is easy. This is not to propose a secret military motivation for what we're actually doing. It is, however, to say that he's onto something. That there are reasons why this kind of thing is not really getting at the full potential of digital technology. And as I've gone along, I've thought about this in various ways. And one of the things I realized is that even this idea of what is a musical instrument is not such an easy question to answer, because it kind of depends who you talk to. If you talk to an engineer, they'll say, sure, a musical instrument is a transducer. It converts actions into sounds. True enough. The psychologist might tell you that an instrument is better understood as a mediator. It's something that shapes the perception and the action of the performer. Whereas the ethnomusicologist or the anthropologist might tell you that an instrument can really only be understood within a social and cultural context with which it sort of co-creates. All of these things are simultaneously true, and then maybe it's worth just unpacking these a little bit and what they might mean for design. Personal note here. That's me. I'm playing viola in the Kensington Symphony Orchestra. I have realized in the years of doing this kind of work that actually my own personal experience as a performer, even though I've never aspired to be a professional, actually really strongly shapes the ideas that I have and the approaches that I take to making technology. And if we think about this from a digital and engineering perspective, well, okay, what do I expect from this wooden box with strings and horsehair? it's actually kind of extraordinary. I mean, we're talking about precision on the order of micrometers with extremely low latency, talking about a large number of degrees of freedom spread across a large area. The entire system is nonlinear in multiple respects. That's very challenging for any kind of mathematical modeling. It's multimodal with audio and tactile channels. You got to do all this stuff basically 100% reliably if anyone's going to take it on the stage. And if all of that wasn't enough, then there is also a whole landscape of both sensory motor skills and cultural expectations around this object, the viola. So, okay, so from that perspective, it's actually an extraordinarily difficult engineering challenge to make a transducer of this specification. We do find that there's an area where a lot of progress has been made in recent years, and that is around the mathematical modeling, physical modeling, it's sometimes called, of acoustic musical instruments. So you can make a numerical simulation of a violin, for example, and you can feed it things like, the bow parameters and where the fingers would be placed. And you can run this model, and out pops an audio signal of what it would sound like. And you can even do this on sufficiently high performance computing so that it can be done in real time. We still have a problem. And the problem is, of course, right here. And how do we capture that richness of interaction between the performer and the digital numerical system? There's a real bottleneck here. Oftentimes what we end up with then instead is something that looks a little bit more like this. Basically a cheapo MIDI keyboard. And you have this sort of sense that you've built this, this beautiful miniature world, and you've sort of sealed it inside of a glass bottle, and you can only sort of peep in through the tiny little hole. And there is a long way to go. So what I am proposing is that a key technical challenge for engineering in digital musical instrument design is not computational speed. It's not necessarily even numerical modeling of sounds. It's the physical and digital integration. And that's a challenge that's probably shared across a number of domains beyond music. So that's the instrument as a transducer. What about mediation? One of the things that you will find is musicians will tell you that the instrument basically kind of acts as an extension of their mind and body. And this has been studied from various kind of cognitive science perspectives and also sort of phenomenological perspectives to ask, what does this mean for the instrument to essentially become a kind of prosthesis or an extension of the mind and body? And what might that mean for design? One of the big issues here has to do with sensory motor skill, because this doesn't emerge overnight. This is something that happens as a result of a long time process of skill learning. The other way of looking at this is to say, well, actually, instruments as objects are maybe that's not the point at all. Anything can become a musical instrument. You can tap a pen on a table, and that's an instrument. You can bang some spoons together. You can blow through reeds of grass. And so it is really the relationship between the performer and the object that produces the instrumentality. Here, I really like Tim Ingold, who is a cello player and writes really beautifully about a number of subjects. But he talks about how, in playing the cello, it sort of ceases to become a recognizable entity at all. He says, what had become a recognizable coherent entity becomes something more like a bundle of affects, a meeting of bow hair, rosin, metallic strings, wood, and fingers coupled with resonant air. Bundle them together and sound erupts as through a fissure. So, I mean, I love this description, and it speaks to me as well. It's the object status of this device is in some ways not the point at the moment that the performance actually starts to begin. But nonetheless, what are we going to do with this? Come back to that. So finally, the instrument as in ecology. Here I turn to Simon Waters, who talks about how it's not useful to think of musical instruments as objects. Basically, again, we have, basically their status as musical depends on essentially a context of use. And so maybe we shouldn't be thinking about you design first, then you place it into a context. But essentially, we are co-designing the context and the technology. The ecology emerges from the more focal technical design processes. Okay, so the crucial issue there then is cultural context. Now, let's go back to this then. This is all well and good, right? And, okay, fine. Loads of quotes and fancy language about stuff. But the real question is, so what? So what? Okay, what should we actually do differently because of all of this? And in particular, how should these ecological perspectives about, instruments as processes rather than objects, or, designing contexts for musicking, if I sit down at the lab bench and I want to write some code or build some circuits, what should I do differently because I know all of this stuff? That's a really big and really sticky kind of question, but it's a really important one. Here I'm going to quote from Christopher Frauenberger in this paper, Entanglement HCI, which I heartily recommend, talking about the extent to which digital technology shapes who we are means that whoever shapes technology puts the chisel on humanity. In designing an instrument, you might implicitly also design an instrumentalist, and that is a position of responsibility. So this is basically the kind of underpinning of a research grant that I started last year called RUDIMENTS. This is an ERC Consolidator Grant, which, because of various political contingencies, is now funded by UKRI, and it runs basically until 2028 at Imperial, and has supported a really cool team of people to work with there. So I'm very grateful for that support. The essential question here is around that, the kind of design turn from some of these entanglement theories. What do we mean by entanglement? How should that actually change our design perspectives? I'm going to unpack that throughout this talk, but just to say that I think this is actually a really important question to be asking now in light of underlying shifts brought about by embedded computing and by AI. This is not a project to say, can we use AI for music? Look, it's already being done very, very widely. It's transforming musical practices in many ways. That's fine. It's super interesting. But I think there's some real questions. Who is doing this? Toward what ends and what values are being reflected right now in the use of technology in music making? So yeah, there's real questions of sort of ethical and social responsibility that maybe these entanglement theories can help us shed some light on. That's the hope. Okay, what do I mean by entanglement HCI? So, here's where we sort of start on a kind of theoretical deep dive, and I'm not going to go into great detail about this, but entanglement HCI was a term which, to my knowledge, was coined by Frauenberger as a way of drawing together a kind of motley crew of post-humanist theories and relational ontologies. Basically, what we're saying here is we cannot study individual things in isolation, not because it just is inconvenient to do so, but actually because things literally don't exist in isolation. At a fundamental ontological level, things only exist in their relationality. That is the proposition that underpins a lot of these kinds of theories. And so what are we talking about here? We're talking about things like Latour's actor network theory. We're talking about Don Ihde's post-phenomenology around human-technology relations. And I think, for me, especially resonant is the agential realism proposed by Karen Barad, which is actually building on a basis out of quantum physics and certain kinds of notions of indeterminacy and kind of entanglement of observer and observed to make a fairly far-reaching theory about, essentially what we can claim exists and what our responsibility as scientists and engineers might be. So the idea is that humans and things are ontologically inseparable from the start. Entanglement theory tends to reject dualisms, the idea that there's nature over here and culture over there, and those are separate, or that you have a kind of that there's the intentional mind versus inert matter, or mind and body. All of these kinds of neat separations oftentimes are challenged by these entanglement theories, and some of these entanglement theories are also rejecting what is known as representationalism, which is the idea that there is a sort of underlying reality that then we come up with words and scientific measurements for that somehow represents that underlying reality that was there before we started looking and will remain there after we stop looking. And again, this coming out of certain kinds of quantum ideas that essentially by building the apparatus of observation, you are sort of crystallizing certain states of being, and that sort of even the idea of observation is an intentional act that has consequences. So again, it's this. I am not doing this justice in any remote way. I am not a really good presenter of this. I would encourage you to read Frauenberger's paper and then go to look at some of the primary sources to really get into what this is all about. But that's the context for what will follow. Now, And now for something completely different. I want to tell you a story about two augmented pianos. These are very specific projects that have come out of my research lab at different times. And I'll show you what they are. I'll play some little videos. And then I want to tell you what I think that means in relation to this idea of entanglement HCI. The first project is called the magnetic resonator piano. This is actually where my music tech career really started all the way back in 2009. It is literally an acoustic grand piano, but it's more than that because inside of it are placed these electromagnets that they cause the strings to vibrate without being struck by the hammers. And the way that all of the thing is controlled is with a scanner that goes on the keyboard to measure not just note on, note off, like a MIDI keyboard would do, but actually the continuous angle of the keys down to kind of a sub-millimeter sort of resolution. And then there is a computer in the loop, which is doing a kind of mapping or relationship between the keyboard, the performer's actions of the keyboard and what happens inside the instrument. The idea being, though, that you're not too preoccupied as a performer with thinking about the computer. You can kind of think through it to the things that you want to have happen. Again, the instrument kind of becoming an extension of your mind and body. I motivated this work at the time with this question. How do you play this on the acoustic piano? So musicians in the room will know that, of course, this is an impossibility. A note that begins softly, gets louder, and gets softer again. You can't do this on the piano because, of course, the piano is actually a percussion instrument in the traditional classification schemes. You press the keys, it causes some hammers to strike the strings, and then the notes decay. And what you don't get out of this is anything like the ability to continuously shape the sound of a note. Kind of a bummer, kind of a limitation, perhaps, of what the piano is capable of. So what I thought was, well, maybe there's other ways of making the strings vibrate. Maybe we can do this instead. We can use electromagnets to vibrate the strings. I am not the first person to think about this. This goes back many decades, actually. But the basic premise is piano strings are made out of steel. Steel is ferromagnetic. That means you can pull on it with a magnetic field. So turn the electromagnet on, the string comes up toward it. Turn the electromagnet off, the string goes back down. You can essentially switch it on and off at the natural vibrating frequency of the string, and it will actually speak quite loudly without amplification, just by way of these electromagnetic fields that you feed into it. So as promised, I'll play you a little demo video of what this is about. Hopefully I have not checked my sound, so I hope this is going to work. Does it go through HDMI or do I need to? What? Do you want me just to mic my computer speakers? Okay. Okay. Well, this video is also online for anyone who's watching. Right, so you get an idea of what that's about. Basically, all those are acoustic sounds elicited by the magnets, but basically it's a kind of cooperation between the acoustic technology and the digital. After I built this, I started working with quite a lot of different composers and performers, and a whole bunch of different projects have come out of this. There's several dozen pieces that have been written for this instrument. Now it's been used in operas and albums of different genres. It's been used in film scores, what have you. And actually, at this very moment, the kit's in Paris, where it is being used in the film score project. And there's lots of stuff that's still going on 15 years later. I'm not going to talk in great detail then about the kind of tech about how this works, because it's not exactly the point that I want to make, but I'll tell you a little bit later about what I think this means. I am in the meantime going to tell you about a different project, which was also an augmented keyboard, which immediately followed the magnetic resonator piano in my career. So this was kind of like 2010, 11, 12. I did a lot of this work. It's called touch keys. The premise here being that you can put capacitive touch sensing on the surface of the keyboard, measuring the position of the performer's fingers, and from that essentially give them the ability to modulate the sounds that they're playing in new ways without actually having to take their hands off the keys. So I'll demonstrate this with a video again. Right. So I think, the idea is hopefully clear enough. Move the fingers around on the key surfaces and get an additional degree of freedom out of your playing. The underlying idea was that basically the whole thing's based on capacitive touch sensing, where there's a discrete number of sensors and you're essentially interpolating readings between adjacent sensors in order to get a quite micro resolution reading of where the fingers are and also the size of the touch. So that actually, even though we have about, I don't know, maybe about 17 sensors down the length of the key, you can have over 1,000 points of resolution. So it's quite micro scale, and which is a thing that I tend to like in the instruments I design. Having built this, there was a question about what then to do with it. And actually, what I ended up doing was taking it to crowdfunding on Kickstarter, which at the time was relatively new for doing these kinds of hardware projects. And the idea here was partly commercial in nature. I did spin out a company out of this afterwards, but actually at least as much as that, it was the idea that for anyone to make music with an instrument like this, it needed to be out there for them to use. And for them to be able to use it, I needed to be able to build them. And to be able to build them, I needed to be able to fund that, and so there was this kind of confluence of reasons why crowdfunding was useful. So that was about 10 years ago now. This too has been picked up by various musicians. There's lots of people who have these, but there's some relatively recent projects that have come about in maybe a more kind of experimental bent, including Zubin Kanga's current UKRI funded project called Cyborg Soloists, where he's commissioned some pieces for these instruments. Now, thus ends my little interlude about two keyboards. The thing is, for me, with touch keys at the end of this, at some point, I started feeling kind of dissatisfied about this project. And I just felt like, okay, Zubin's figured this out. Paula's figured this out. They're doing really interesting things. I have never figured this instrument out. I built the stupid instrument. I don't actually know what it means to me musically. And I think that I've missed the point somewhere. Like I've really foundationally missed the point of why I did this project. And and in thinking about that, I think I realize that, it taps into something that I think is maybe a broader issue that faces the field of digital musical instrument design. By way of explanation, touch keys is essentially a MIDI controller, right? It's a way of extending the kinds of things you get in your digital audio workstation. So let's have a little historical review of what we mean here by MIDI. 1985, 3 years after MIDI was first formulated.
About 3 years ago, musical instrument manufacturers got together to decide on an interface system that would allow anybody's electronic musical instrument to connect to anyone else's. And they came up with MIDI.
Very good. So let's find out what MIDI is about.
Turn down the synthesizer so we can now only hear the piano. So what information can we send? I think the most important is key event information, which will tell the piano which notes I'm playing and when I'm playing them. And we'll also send dynamic information, which is how hard I hit each note.
Okay, so now the ideology is starting to come into focus, right? Key event information, which notes I hit and how hard. Okay, so we carry on.
So by using MIDI, up to 16 different instruments can be independently controlled because you assign each one a MIDI channel number. And this is really useful when they're to be played by a sequencer or a computer. Yes.
I love that. I love the 80s bit of this. But you know, hold on here though, because something really controversial just happened here. We went from key event information to up to 16 different instruments can be controlled. So the premise is that all of these different instruments in the world, you know, strings and brass and what have you, are responsive to which notes I play and how hard. I think that's a really dubious proposition. And frankly, as a string player, I'm very offended by this notion. But you know, it's worth thinking about. You know, MIDI is not just this thing that's been handed down from on high and is just sort of in the water of music itself. It's a very specific thing that was built by a collection of basically a self-appointed consortium of North American and Japanese companies, for the most part, which were interested in selling more products by having interoperability. It was also the early 80s, so they had to make lots of simplifications in order to make this tractable for the computation of the time. So they come up with all sorts of assumptions, like, you know, music is made of notes. Really? I mean, okay, so you can notate a score and you could reverse engineer that into something, but are notes really the, sort of the fundamental constitutive element of music? No. Starting with, there's tons of different kinds of music in the world, and then also even any classical performer will tell you that what's written on the page is only a small fraction of the actual performance practice. The other thing it assumes is that notes have discrete onsets and releases. Again, that works great for the piano and basically no other instrument. It certainly doesn't work for bowed strings. MIDI assumes, for example, that notes are organized 12 to the octave, typically with equal temperament. Again, ideology of the piano imported into digital technology. But the thing is, we're 40 years on from this now, and so much music around the world has now inherited these assumptions. And the influence of this technology on aesthetics and culture is absolutely profound. And you know, who knew at the time, the early 80s, that that this was going to have those kinds of effects? I think it's really important to unpick these values when they come up, and I think that's why I'm saying, you know, with AI and embedded computing kind of becoming increasingly important, now's a really good time to be thinking about these questions. Now, you might just say, oh, you know, well, you know, good thing us academic instrument designers are much more enlightened than that. You know, that's just a bunch of, you know, commercial nonsense. And, you know, really, good thing we've got Max MSP, so we're safe. Doesn't quite work that way. The problem that I would describe is I would describe this as a kind of problem of design by analysis. When people create instruments, this, by the way, is me and touch keys also. This is my autobiographical account. It goes kind of like this. I want to make an instrument in order to make music. What do I mean by music? Well, I may not be very clear about that to myself, but I probably mean some particular style of music that is relevant to me personally, but I'm just going to generically say it's any music you want it to be. Now, here's where the real problems start to come in. I start to think, well, how do I make music? Well, what words do I have to describe music? How can I represent music? How can I conceptualize it? And so if what I'm thinking about here is something like, you know, keyboard music, for example, then maybe I can, you know, come up with some qualities about this. I could say, you know, a pitch, i.e. note or velocity, like in the MIDI example. I could talk about, you know, the timing, or I could talk about, you know, which voice I was playing with those 16 different channels. But maybe I say, I don't want to be limited to that. Why don't I add some things? I'll add timbre, I'll add spatialization, I'll add audio effects. You know, the sky's the limit. And what I then do is basically take those words that I have to describe music and I put them on numerical scales, and I make little numbers out of them. And what emerges is a dimension space, an n-dimensional space, which I guess the proposition is that music making can be aptly described as a navigation through this multidimensional space. And I guess the problem I have with this is that this might be a perfectly reasonable analytical trope. I am not sure that it's a very effective generative trope to think about things this way, that all you have to do is essentially lay things out in a spatial metaphor, navigate the space, and hey presto, you've made music. But then what we do next in our design process looks like this. We open our toolbox and say, good, what do I have here? I've got some FSRs, I've got some IMUs, I've got some potentiometers and these great piezo discs. Okay, pull out my favorite computer music language. And what I'm going to do out of all of this business is I am going to create a different dimension space reflecting the performer's interaction. I might say this is gesture quantified. That I'm going to represent gesture numerically according to some kind of numerical space. Having done so, then what I do is I say, well, okay, I'm going to draw some kind of associations between this space and that space. Might be one-to-one, might be many-to-many, could be done with machine learning, even lots of things you could do. We call this process mapping. And you recall I already used that word in describing what the magnetic resonator piano was doing. My problem isn't that mapping isn't a good isn't an important thing to do, or that it can't, that doesn't produce useful results. It's that I think that we've kind of turned the whole process upside down in starting from the analytical concepts and trying to design towards them, rather than saying that the analytical concepts are essentially analyzed out of experience and out of perception. And it's taken me actually quite a few years to come up with any sort of language to describe what I even mean by this. I found this short paper by Philip Agre to be really productive. I would recommend this to you. It's called Towards a Critical Technical Practice, Lessons Learned in Trying to Reform AI. It's from the late 90s, but it's about so much more than AI. And he talks about how computers are representational artifacts and that they don't simply have an instrumental use in a given site of practice. They're actually about that site in its very design. And so he says provocatively that computing has been constituted as a kind of imperialism, says the guy from Imperial College London. It aims to reinvent virtually every other site of practice in its own image. What I'm getting at here is that I think that mapping can become a kind of form of representation design, that we've essentially started with this premise that we have a conceptual space of words and numbers that is representative of this abstract underlying quantity called music, and that essentially by manipulating this representation, we are therefore creating music. And I think the other thing then is that these digital instruments designed this way are kind of nice, because if you have managed to represent music numerically, then just by looking at what the computer is doing, you also kind of have a built-in music analysis. You have a built-in music theory just by looking at how these numbers are moving. But I think that idea that the machine should somehow know what it's doing according to music theoretical terms that we could just kind of peer in and see, that's a choice. That's not an inevitability. The machine doesn't have to understand music on the same terms that we do. But I think when you design this way, it encourages thinking that tries to align computer and machine. And that in turn, I would say matters because we have to think about whose music is being encoded into these systems. Music is not a monolithic universal entity. We have to think about in what context might we expect an instrument to be played, what aesthetic ideas would it suggest to the performer. Thor Magnusson is an author who writes really well about this, talking about, the piano keyboard tells us that microtonality is of little importance. The drum machine tells us 4/4 is the most natural kind of rhythm, etc. You could make a more general argument here beyond music, which is that essentially the tools we use influence the way we think. So, Arduino has been with us for, lots of years. Amazing tool. I love it. I love it to pieces. And yet, it didn't take very long for articles like this to be written about the kinds of things that people do over and over and over again with physical computing, certain kinds of things like data gloves and tilty controllers and such. And in the music space, especially this idea of making a theremin-like interface, by which we mean not necessarily that you've made radio frequency antennas, but the idea that you organize music into X, Y spaces, and you say X is pitch and Y is amplitude, and that's job done, music made. Or the way that other boards like the Makey Makey, the touch controller leads lots of people to kind of reinvent ideas like the banana piano, that essentially, that you turn fruits into a keyboard. And Emily Dolan is a very interesting musicologist, talking about kind of how keyboardness has come to dominate musical thinking, especially in the West. Where am I going with all this? Well, I have a paper that is coming out at CHI this year. This is with Landon Morrison, who is a musicologist, who's a music theorist and media studies scholar, who is a postdoc working with me on the RUDIMENTS project. And this is us trying to grapple with all of this entanglement HCI stuff, kind of reading it through the lines of music practice and music theory, and trying to find kinds of patterns of resonance and patterns of friction between these different disciplinary bases, to kind of ask ourselves, why are we designing the way we are? What else could we be doing? And what does all of this mean? So I'd say basically the paper, in all honesty, is a bit dense. There's a lot of theory in there, but we touch on a few different things around why keyboards are really central to musical instrument design. This question of inverted analysis and the touch keys thing I just told you about as a kind of example case, and then maybe try to ask about what else we might do. We also kind of throw a few provocations out there aimed at a CHI community. For example, there is this proposition that entanglement and post-humanism is perhaps the next wave, what is going to succeed third wave HCI. Is that really the case? What else might be there? Who is invited to this conversation and who is excluded from this conversation within these kind of post-humanist theories? And then we then toward the end get into this discussion of what Donna Haraway calls the God trick. So Haraway writes this really a number of really interesting articles, but this one is called Situated Knowledges, and it's essentially trying to grapple with a sort of feminist approach to scientific practices, and kind of to getting beyond these ideas of sort of universalism and objectivity, and to ask, how do we understand what we are doing as scientists and engineers? And kind of getting beyond these poles of either total universal objectivity or kind of complete cultural relativism. And the God trick, as Haraway calls it, is the idea of seeing everything from nowhere, kind of like, reality exists, or, these things exist, and I don't tell you from what perspective I make that determination. I just sort of assume this kind of, sort of view that floats above it all, and that I can just sort of see the world in complete clarity, and that's actually not how things really go in so many areas of practice. And so Haraway is arguing for this idea of partial perspectives, the possibility of sustained, basically that from these situated perspectives, you can get certain kinds of actually paradoxically more objective inquiry. Some open challenges around this is basically, we have to consider our position as researchers. What are we doing? How do we relate to institutional structures, to funding structures, to social structures? We don't get to just sort of say how the world is as an objective universal view from nowhere. There's a whole kind of language that comes out of Haraway and Barad around this idea of diffraction as a kind of metaphor instead of reflection. I find this really productive. But I think that we don't want to lose some of the critical insights that come out of third wave HCI in terms of reflexivity and that kind of thing. So how do we line those up? And then what I would suggest is, when I wrote this proposal, this RUDIMENTS proposal, I was talking about this idea of entanglement design, i.e., if everything's related to everything else, what am I supposed to do as a lowly engineer who's just going to build a musical instrument by doing code and circuits and that kind of thing? How do I even make sense of this? How do I do anything at all when everything is so kind of hopelessly entangled? I think the critical problem that I had in the framing originally was the idea that entanglements could be a thing that would be designed as if somebody could stand outside of that and design an entanglement. In reality, I'm already part of the entanglement. We're all part of the entanglements of the practices that we undertake. So this idea of entangled design, how do you work within the perspectives that you have, understanding that you are always a part of the story that you were writing? That I think is an interesting and open question. Okay, so in that spirit, I'm just going to close by returning to this slide here. See, this really abstract theory does connect to augmented pianos in some ways. How do we do this on the piano? That was what I said I was doing. Okay, no, can't do that. The piano is too limited as an instrument. Here's the thing. This is a total lie. It's a fabrication. I did say these things. I had these literal slides in 2010, 2011, but it's actually not the reason that I did this work. And it took me so many years to realize what was actually going on here. This kind of explanation, I think, it is a bit of a view from nowhere. Here is, the piano as this thing that exists but has these limitations, and now here I am, the heroic designer swooping in to solve these problems by the aid of digital technology. What was actually happening was that I was going through a particular kind of career trajectory, which is, now at this moment in time landed me at Imperial College London. But I was going through a PhD in music composition, based on a background in electronic engineering and in music. And I was a viola player. I am a viola player, as I showed you earlier. And as of the end of my PhD, I had almost no compositions for solo piano. And that's because it was frankly too hard. If you don't play the piano, how do you know what fits under the fingers? And also you have like 300 years of all this amazing music, and it's just so intimidating. How do you write something for solo piano after, all of these incredible composers? So what I think was doing now, retrospectively, was not fixing the piano or making it better. It was about changing what the piano was about just enough that I could have my own creative inlet to it. And that let me write this piece for my dissertation called Secrets of Antikythera, which is like a big, long 40-minute piano piece for magnetic resonator piano, the first piece for magnetic resonator piano. I was building the tech and I was writing the piece at the same time. But the story didn't stop there because, as you saw, it went on to be used by lots of other composers. And I think and that's really actually what's made it a lot more interesting. If it had been just this, it's fine. I'm proud of the piece. But if that had been the end of the story, I think it wouldn't have been all that interesting. It's what other people do with it that it continues to surprise me. So I'm going to play you, this is the last video I'll play, and basically nearly the last slide. And this is Xenia Pestova-Bennett playing a piece called Blowing Radioactive Elements. Anyway, so what the heck is going on here? Xenia has found this incredible way of kind of getting into the cracks of the instrument and kind of pulling them apart in a way that has discovered these sounds that I had absolutely no intention of creating when I designed the instrument. What she's doing is she's discovered that when you hold the key just so, there's a certain kind of electrical noise on the scanner that interacts with what are effectively bugs in my software, switching between different states, which produce these really strange glitchy sounds that then go into the magnets, which are amplifiers that are very nonlinear, where the damper is just lifted off the string. And all of this then, of course, sits within a context of a certain kind of experimental performance practice. Basically, everything has to come together to produce this particular effect. Change any element of the system and it disappears. And I think this is a potent metaphor in some ways, and also just a really interesting example case of where I think to make sweeping universal statements about how things work is oftentimes elides the interesting details. The interesting details emerge from situated bits of practice and oftentimes surprise us. And that has been the kind of ongoing story of this whole project. And one that I think I'm now, maybe kind of grappling with, as you'll see, kind of how to fit this within a broader context. but it's been a super interesting journey. So the thing I'll leave you with is, once again, Philip Agrate, basically, he talks about this idea of a critical technical practice. This idea that, critique is nice, but how is this actionable? So he wants to see, the critical technical practice is something that has one foot planted in the craft work of design and the other foot planted in the reflexive work of critique. So in the case, at least, of designing musical instruments, this is not about solving problems, it's about engaging in certain kinds of artistic conversations. So hopefully that's a conversation that we can continue here now. So thanks very much.
Great show of question. So this is not an amplifier, by the way, it's just for the people online.
Thank you. That was really, really super inspiring. And I really like this. I haven't read the original Entanglement paper, but I can really relate to some of the things. And I think that a lot of the people who do HCI around sort of like making and hacking and a bit of the sort of perhaps also research through design, I think are consciously or unconsciously influenced by that. That's really, really interesting. Thank you for that. My question is around the grant that you mentioned, because you said that this work is sort of supported by that, but is it at the center of the ERC? We don't talk about Brexit thing, or is there like a part of a different picture? Can you tell us more about that, just out of curiosity, really?
Right. So the ideas that I presented just now, the RUDIMENTS project, which is this ERC Consolidator Grant. So it is for all intents and purposes, it's an ERC Consolidator Grant, submitted to, selected by, awarded by ERC, which then had to be funded by UKRI because it fell into this 2-year gap of political stalemate between the EU and the UK. Bummer. But anyway, it's fine. It's great. That project is what's supporting Landon's time, supporting some other people on the team. And I think this idea of these kind of humanities-based and also sort of post-humanist ways of thinking have become fairly ingrained into the conversations that have been happening in my research lab generally in the last couple years, driven to a large extent by this. And so the hope, where we are in the project right now, is basically we've spent about a year trying to lay some theoretical foundations, and that's that Kai paper that I linked to, amongst other things. It's essentially, this is not yet proposing new design practices. We're not there yet. I'm showing old design practices, not because I'm saying that these already solve that problem, but because I'm saying this thing seemed to work, this thing seemed to not work. Why did that happen? And the more I ask questions about it, the more I realize that actually usually the answer seems to be even a layer deeper than the last time I looked at it. And that's where I'm finding some of these theories, like the agential realism of Barad, or some of Haraway's critiques, to be particularly useful to kind of just rethink what values we are expressing. Now, after that, we've got 4 years left on this project, and so the hope then is to start to build up maybe different technical frameworks. What does an alternative to the kind of design by analysis look like that I just presented? I mean, I've got some ideas, but they're too speculative to waste your time with here. And so, talk to me in a few years and we'll see. But even when we're done with that, I mean, I wouldn't be so kind of arrogant as to say, okay, well, now we've really discovered the way that we should do it, because the whole point is that there isn't one way to think about these things. It's just, it's a coming to terms with, I think, a lot of related factors that, yeah, that's where we're at.
Sorry, quick follow-up. Have you already looked for existing design practices that may fall outside this one, like whether in your own work or elsewhere?
Yeah, okay, so to get a little bit into where I'm looking at right now, if you look at so this idea of kind of mapping, for example, it's one of the kind of underlying premises, at least as it's implemented in digital systems, is this, it's a little bit of a kind of command and control kind of relationship. Here's the output that feeds to this input. You know, the data flows from this in this direction, except when I decide to close the loop with some kind of feedback at the end. And I think it's no surprise that some of the most experimental and unusual practices involve some kind of feedback. There's a kind of conceptual alignment between sort of words and concepts and symbols and numbers in a lot of these systems. If you, a contrast you could draw would be to an acoustic instrument, for one, where everything flows in both directions. I mean, the strings couple to the soundboard, but the soundboard couples back to the strings. When you bow the strings, the reason it makes a pitch to begin with is because the kind of stick-slip process of friction causes this little pulse to physically travel down the string and back again. So I'm wondering whether maybe ideas of kind of unidirectional signal flow could be replaced with a sort of notion of finding equilibria, like kind of things sort of settling out by way of sort of data and information flowing in both directions until the kind of stable points of the system are found, and that system would include essentially sort of the intentional actor, I mean, the human performer, that kind of thing. I have the sense, but have absolutely no referencing for this, that actually earlier notions of analog computing might be an interesting alternative to look at compared to digital computing, where if you wanted to solve a differential equation, you essentially plugged in the cables in a particular way and then just watched the system kind of find its way to an equilibrium, and that was your solution. And that's a little bit different than kind of iteratively grinding through approximations until you get somewhere. So yeah, I don't know. I mean, I think I'm looking to other domains. I'm looking to maybe historical practices just to ask, yeah, what else?
Yeah, I was thinking like, so it sounds like a modular synthesis is like something that people have been doing, maybe also coming from other directions beyond the keyboard, I guess.
Yeah, and modular synthesis both sort of is and isn't the answer in a way, right? Because it's, you know, I like the, you know, I like the configurability of that, and I like the often analogness of it. On the other hand, it does still subscribe to this notion that here's your output with a low impedance, here's your input with a high impedance, and that the system has idealized properties, that the outputs shouldn't be loaded down by the inputs, so that, you know, signals always flow neatly in the direction that you send them. Yeah.
Thank you.
Thank you. Hi, Andrew.
Hey.
Hello again. Thank you again for this presentation. It was really, really nice. I've been kind of attending a few different versions, and every time I just like get hugely inspired by your work. So I was also kind of thinking about the question that you were asking about, like different methodologies, design methodologies that could be applicable to this, well, not yet defined approach. But looking back at some things that I got in touch with in the past in my research, like action design research, like things that are inspired from that ideology of Sean's, the reflective reflection in action, applied to the design methodologies that, rather than adopting this design by analysis, they look at the broader context, look at the values of society, and try to ingrain all of that into the artifacts that are produced, and try to fight off like what is the attribution error of designers, which take their assumptions and somehow ingrain it in the artifact against. So these are methodologies that have been established mostly in information systems, for instance, and that have been used to design computational artifacts, systems, social technical approaches that, you know, include you know, a broader frame into design. So I think it's really difficult. I mean, I think I would have like lots of questions to ask you about all the different kinds of levels that you've presented here, like from the more abstract to the more design, more technical. But something that stands out to me, it's this tension, which I also feel that's unresolved, which is, for instance, when you consider that the music technology industry basically evolved to respond to what are requirements of mass production, which is based on economies of scales but also professionalization of the roles of musicians. So how can you standardize things so that you can create careers or established careers that have longevity, and they're not just like local phenomenons that just relate to music improvisation, but are like long, sustainable, profitable things. So when you look at, for instance, that approach in the music and music technology industry, and you look at more localized musical phenomenons, such as a bunch of friends that just gather up and they want to improvise music with whatever is at reach from them. So those are two very different things that an approach to musical instruments design to reconcile is something that is, I think it's extremely difficult. So how do you go about, I don't know, encompassing this landscape of possibilities in the theoretical, empirical design? I mean, it's
where do you even begin? Yeah. I mean, I think you're right to highlight a lot of this kind of, you know, the reflexivity and reflection and action. I mean, these ideas that we take account of our positionality. I mean, it's not like that was just invented yesterday. This has been around for some decades. And so I guess you could reasonably ask, well, what does all this post-humanist stuff really bring to the table that people haven't been just saying this? Have people just been saying the same things for 30 years, just with different words? That is one of the provocations that's in the paper. Is, you know, essentially, have we just come up with a new vocabulary to describe exactly the same thing we already understood? And I don't think so. And I'm not sure I can put a great point on this, you know, here extemporaneously, but I do think that there's a way that even the kind of the sort of fixity of roles and identities and boundaries between things that even seem to have very obvious independent existences. I think when you start to actually question where those are and how those come to be constituted, I think that's one of the contributions of the sort of post-humanist take on this that can be useful as a design aid that goes beyond maybe even just some of the kind of some of the reflection that you might otherwise bring. In regard to the question about commercial mass production, there's no question. I mean, and this is why this kind of work, you know, the boundaries don't stop at academia or music or whatever. They get into economics, they get into politics and whatnot. But it's not quite so simple as just saying mass production bad, custom stuff good. Because if you look at what some of the more transformative objects are, if you want to just look at objects, turntables, 808s, you know, this kind of thing, things that were mass produced.
The electric guitar.
The electric guitar, things that were mass produced for one reason, which were appropriated by certain communities in certain situations, sometimes coming from, you know, a landscape of economic scarcity, and essentially from there new practices have emerged. And the fact that those things were cheap and ubiquitous was actually really important. And it didn't make the music homogeneous necessarily either, but it did have some kind of influence. So how do you account for that? You don't want to just, you know, throw the baby out with the bathwater and just say everything's bespoke technology. Because anyway, if everything's bespoke technology and tomorrow's a new bespoke technology, we've made ourselves a real e-waste crisis as well. So, you know, you see, you know, I think, yeah, somehow I think that's why it's about kind of looking at these sort of contingent situations that emerge. This technology in this particular social and economic context with this particular goal, and here emerges an interesting side of practice, and then you reconstitute it somewhere else. And yeah, and so the question then is how do we as designers start to enter that conversation knowing that whatever we set out to design is probably going to be boring, but the thing that we didn't expect to happen is going to be the thing that's interesting, because that's what keeps happening. I don't know if that answers any of the questions. Yeah.
Thank you.
Yeah.
Thank you very much.
Okay. Well, thanks. Yeah. Thanks. Thank you. Happy.
Obviously, today I've got more questions. It was
Yeah.
Thank you.